Let us go to question number 21. For two gases A and B with molecular weights Ma and Mb, two gases A and B, molecular weights Ma and Mb, molecular weights Ma and Mb. It is observed that at a particular temperature T, the average velocity of A, that is C bar of A, is equal to, C bar is of course equal to under root 8 RT by pi molecular weight of A. The average velocity of A is equal to RMS velocity of B. RMS velocity of B is equal to RMS velocity of B, that is under root 3 RT by Mb, and these two temperatures are same. So, basically the given is that under root 8 RT by pi Ma is equal to under root 3 RT by Mb. So, from this basically what we can get is that, so if you take this, then square roots if you cancel, then R, T, everything gets cancelled, then the ratio of Ma by Mb, what you will get is Ma by Mb is equal to, this is 8 and 3 pi. So, it is 8 by 3 pi, that is the ratio of molecular weights, right. And the average velocity of A can be made equal to average velocity of B. Here average velocity is equal to RMS velocity. Then under what conditions, that means whether increase in temperature or decrease in temperature, under what conditions that average velocity of A can be made equal to. So, that means average velocities if you take, then this is of course 8 RT by pi Ma. Now, if you write this is 8 RT by pi m, must be equal to 8 RTB by pi Mb. Now, this Ma Mb relation already we got. So, if you take that in any one, then Ta Tb relation also what easily you can understand is that for these two to become equal with the given Ma Mb ratios, that if you substitute over here, what easily you can understand is that the Ta if you lower and Tb if you increase, because here this is the ratio is root 8 is to root 3. So, this is root 8 by pi. So, actually this is the ratio wise if you look at it, this is 1.12 is to 1.22, that is the ratio for them, or root 8 by pi is to root 3. That is what from here we can easily look at into it. So, that way if you look at it, for these two to become equal, Ta must be lowered and Tb if you increase, then these two can be made equal, because this is originally equal to what 3, now this is increased. So, for this, as this is increased 8 by pi, this is root 3 is greater than root 8 by pi. So, this become less, this become less means to make it equal to this, what you should do, either Tb must be increased or Ta must be lowered, right. So, the correct answer is option 1. Next, question number 22. This question is again on the concept of compressibility factor. The compressibility factor of a gas is more than unit E, that means Z, that is PV by RT. PV by RT is greater than unit E, that means PV is greater than RT. Therefore, at STP, what will happen? Vm must be greater than 22.4 liters, because this at STP if you take PV if you made equal to RT, then V you will get it as 22.4, but pressure and temperature keeping constant, that you are writing PV greater than RT. P is normally PV equal to RT for Z equal to 1. In this case at standard pressure and standard temperature 1 atmosphere and 273 Kelvin, V is 22.4, but now PV is greater than RT. P is same, T is same, but relation is not equal, it is greater. That means what? volume must increase. So, it should be greater than 22.4. So, the answer must be first option. Now, question number 23. Now, the question is van der Waals constant B for helium. Van der Waals constant B for helium is given as 2.433 into 10 power minus 5 mole cubic meter per mole. Cubic meter per mole. This value is given for per mole, cubic meter per mole. So, per atom, therefore, per atom this B is equal to 2.433 into 10 power minus 5 by 6.023 into 10 power 23. This is approximately 4 into 10 power minus 29 cubic meter per atom. And this B is equal to, from van der Waals constants, from the way that we have derived the constant B, this B is equal to 4V. So, when this B is equal to 4V, so from this, where V is the volume of each volume of that atom, volume of the helium atom. Okay. So, V is equal to 4 into 10 power minus 29 by 4. This is approximately 10 power minus 29. Now, therefore, V is equal to 4 by 3 pi r cube, that is equal to 10 power minus 29. Now, from this, if you calculate, what you will get is that R, you will get it approximately as 1.34 angstroms, or you will get it as 1.34 angstroms. But the question asked is diameter. So, diameter is equal to 2R, that is equal to 2.68 angstroms is what we will get it. So, the correct answer is the second option, 2.68 angstroms. So, this is what the derivation is. Okay. Now, we go to the question number 24. The question is the ratio of most probable velocity, average and RMS velocity of gas molecules is a simple direct question on the formula. Cp is equal to under root 2 RT by m, C bar is equal to under root 8 RT by pi m, and C RMS is equal to under root 3 RT by m. So, the question asked is the ratio of all the three. Cp is to C bar is to C RMS. This is equal to under root 2 is to under root 8 by pi is to under root 3. This is what the question asked is. And this, if you do it, then this is 1 is to 1.12 is to 1.224. This is the ratio. So, 1 is to 1.128. 1.128 is to 1.224. So, the correct answer is option 2. It is direct formula based question, just it is only the ratios. So, the correct answer is option 2. The next question is again on the molecular velocities. It is Maxwell-Boltzmann distribution curves. When Maxwell-Boltzmann distribution curves in the kinetic molecular theory of gases, to explain, we draw these graphs, according to which when a graph is drawn for a fraction of molecules n by n naught versus the velocity, if you draw a graph at a particular temperature, first what we told is, with increase in velocity, fraction of molecules possessing higher velocity increases, reaches maximum and then decreases. Because it never becomes 0, it decreases. At two different temperatures, when you draw the curve will be like this. With increase in temperature, the peak of the curve will shift towards the right and the height of the peak will decrease. And so, at three different temperatures, then this is how we will get T1, T2, T3 if you write. So, with increase in temperature, the fraction of molecules possessing higher velocity increases. So, that means the velocity of all the particles, all the molecules will increase. So, the peak will shift towards the right, but fraction possessing higher velocity, that the height of the peak will get reduced. So, the answer is that T1 less than T2 less than T3. These are the three different temperatures at which it is drawn. So, the correct answer is option 1. Next we go to the question number 26. Again in the same graph, the velocity corresponding to peak of the curve is calculated. In the same graph, the peak, this peak is corresponds to Cp. This is Cp. This is C bar, just little higher than Cp, and still little higher than C bar is Crms. So, the velocity corresponds to height of the peak. Velocity corresponds to height of the peak is nothing but what? Most probable velocity. And Cp is equal to under root, as just now we wrote, it is under root 2RT by m. So, velocity corresponds to the height of the peak is under root 2RT by m. So, the correct answer is option 4. Now, let us see the question number 27. The average kinetic energy of gas molecule at 27 degrees Celsius in SI units is again straight question. Average kinetic energy is in some of the previous questions as we have seen. Average kinetic energy for any gas molecules is given as 3 by 2 kT, where K is a Boltzmann constant. K is a Boltzmann constant which is R by N, that is R, if you take it in Joule, 8.314 by K 6.023 into 10 power 23. R is the constant per mole, K is the constant per atom. That is the only thing. So, it is a constant, and that if you do that, if you substitute over there at a temperature of 20 degrees 27. So, temperature is given as 300 Kelvin. That if you substitute, what the answer you will get is average kinetic energy. You will get it as 6.21 into 10 power minus 21. Right. So, this is the average kinetic energy in SI units. 6.21 into 10 power minus 21 is the correct answer. This is question number 28. The ratio of kinetic energy of 4 grams of hydrogen and 4 grams of oxygen gases at 400 Kelvin is: hydrogen 4 grams is 2 moles, oxygen 4 grams is number of moles of oxygen is, so 4 by 32, that is 1 by 8 mole. Now, kinetic energy is equal to 3 by 2 nRT. Therefore, at same temperature for different moles of gases, K1 by K2 is equal to N1 by N2. N is 2 by 1 by 8, that is 16:1. So, the correct answer is option 4, that is 16:1. Now, question number 29. At 27 degrees Celsius, the RMS velocity of a gas of molecular weight 83.14 is, temperature is 300 Kelvin, 27 degrees Celsius means 300 Kelvin. Molecular weight of the gas is 83.14. Now, RMS velocity, CRMS is equal to under root 3RT by m, that is equal to 3 into 8.314 joule per mole per Kelvin into temperature 300 by molecular weight 83.14 grams. So, in kg it is 83.14 into 10 power minus 3. That if you take, now it is, this is 10. So, this will become 10 power minus 2, and so this will become 3 into 300 into 10 power 2, that is 900 into 10 power 2, 9000. That if you do it, and in centimeter per second if you convert that, then what you will get is 3 into 10 power 4 what centimeter per second. Okay. So, CRMS is now equal to 3 into 10 power 4 centimeter per second. Here you will get it in, this is in meters, that if you convert this, you will get it as 3 into 10 power 4 centimeter per second. So, the correct answer is option 1. Now, I will go to question number 30. This is once again question on the RMS velocities. Ratio between the RMS velocity of hydrogen at 50 Kelvin and RMS velocity of oxygen at 800 Kelvin. C RMS of hydrogen to C RMS of oxygen at a different temperatures. For anything, the ratio of rates of velocities, whether it is RMS velocity or most probable velocity or average velocity, anything is equal to root over T1 M2 by T2 M1. That means T1 is the temperature of helium, that is 50 Kelvin. M2, that is the molecular weight of oxygen, that is 32, by T2, that is the temperature at which oxygen is taken, that is 800, into molecular weight of hydrogen, that is 2. So, this is now if you take, now this is 550 into 32 16, 800 into 2 is also, this is 1600 and this is also 1600. So, this is equal to 1:1. So, that means RMS velocity of hydrogen at 50 Kelvin is same as RMS velocity of oxygen at 800 Kelvin. So, the correct answer is 1:1, that is option 2. Now, we go to question number 31. A real gas is supposed to obey the gas equation P into V minus B equal to RT at STP. If 1 mole of gas occupies 25 cubic decimeters of volume at STP, then its compressibility factor is. So, as the equation is P into V minus B is equal to RT, PV minus PB is equal to RT, so PV equal to RT plus PB. That means the gas is exhibiting positive deviation from ideal behavior, because now you can say Z is equal to PV by RT, which is equal to 1 plus PB by RT. Now, these values that are given, if you substitute over here for P, B and T, that all values if you substitute, this total factor comes out to be 0.115. So, this is equal to 1.115. Okay. So, it is a gas that is exhibiting a positive deviation, as from the equation itself you can say P into V minus B is equal to RT, and among all the 4 options there is only one value, whose value is greater than 1. So, that is 1.115. So, the answer is 1.115. Okay. Let us go to question number 32. The question says 1 mole of nitrogen gas at 0.8 atmosphere takes 38 seconds to diffuse through a pinhole, whereas 1 mole of an unknown gas at 1.6 atmosphere takes 57 seconds to diffuse through the same pinhole. The molecular weight of the unknown gas is. So, here the pressures at which the 2 gases diffuse are different. One is at 0.8 atmosphere, then the other is at 1.6 atmosphere, and time taken is also different, right. So, here what actually we have to take is diffuse through the same pinhole, the molecular weight of the unknown gas. So, here the one gas is nitrogen, R nitrogen, first of all R nitrogen by R unknown gas, that I call it as Rx, is equal to inverse ratio of times, because ratio of rates of diffusion R1 by R2 is equal to volume of gas diffused by time to which it is diffused. So, V1 by T1 by V2 by T2. If V1 is equal to V2, then R1 by R2 is equal to T2 by T1. So, this I will take it as T2 by T1. T2 by T1, that is equal to, that is T2. T2 is the volume, the time taken for the gas X to diffuse, that is 57 seconds. And this is first gas, that is nitrogen, is 38 seconds. This is so then equal to P1 by P2, directly proportional to pressure, because rate of diffusion is proportional to pressure, rate of diffusion is proportional to number of moles. So, it is P1 by P2 into root over M2 by M1. So, 57 by 38 is equal to pressure at which the first gas, that is nitrogen, diffused is 0.8 by pressure at which second gas diffused is 1.6 into root over gas X, that's molecular weight, which we have to find it out, divided by molecular weight of nitrogen is 28. So, this if you do, this is 2, 1 by 2. So, 57 by 38 square is equal to 1 by 4 into mx by 28. So, from this mx is equal to, 28 square into 4 into 57 square by 38 square, right. This on simplification, what you will get as this is equal to 252. So, the molecular weight of unknown gas is determined as 252. So, here what you have to see, this is a very good question, that ratio of rates of nitrogen, ratio of rates of diffusion of the two gases is inversely proportional to the time at which the two gases are diffused, and also here you are applying the principle that the rate of diffusion is proportional to the pressure at which the gas is allowed to diffuse, and of course, rate of diffusion is inversely proportional to square root of molecular weight. All the factors that you have to take into consideration. So, when all the factors that have been taken into consideration, then this is how that you can take the conclusion. So, from this you can derive and you can calculate the molecular weight of the unknown gas. Here the calculation is not that important, but simple that formula we can take, and how best that we can solve the problem is very important thing. So, the correct answer is option 4, 252. Now, question number 33. This is a question on different conditions at which the gases have been kept. 4 grams of argon, molecular weight 40. Weight of argon gas is 4 grams. Therefore, number of moles of argon is 4 by 40, that is molecular weight of argon, atomic weight of argon. So, it is 1 by 10, that is 0.1 mole, right. Is kept at a temperature of T Kelvin and a pressure of P atmosphere. When the bulb was placed in a hotter bath at a temperature of 50 degrees more. So, here temperature, if you consider at temperature T and pressure P. Now, at T plus 50, at a temperature 50 degrees more, 0.8 grams has to be removed at T plus 50 to have same P. 0.8 grams of argon is removed. This is what is the given information. Therefore, now, so this I will take it as N1, that is given number of moles of argon. N2 is initial number of moles of argon minus the amount that is removed. Now, N2 is equal to 4 by 40 minus, this is the given number of moles, 0.8 grams have been removed, that is 0.8 by 40, right. So, this is 3.2 by 40. So, this is the 3.2 by 40 is equal to 32 by 400, that is 4 by 50 or 2 by 25. This is 2 by 25, that is number of moles of argon after removing. Now, the question is the value of T is, so what is the initial temperature? So, for this what we have to do is, as you know from the ideal gas equation, from gas laws, P is proportional to T. So, P1 by P2 is equal to T1 by T2. Therefore, the P1 is equal to N1 T1 into N2 T2. P is proportional to T as well as P is also proportional to N, because what we have is PV equal to nRT. So, P at constant volume, P is proportional to N and T. So, N1 T1 by N2 T2. Therefore, P1 by P2 and P1 by P2, the P1 is equal to P2 to have the same pressure, means P1 is equal to P2, and the P, that means N1 T1 is equal to N2 T2. Therefore, N1 is 0.1. 0.1 into T is equal to 2 by 25 into T plus 50, because T2 is nothing but T plus 50. So, that you have to take. So, that if you solve, the answer you will get T as 200 Kelvin. Okay. So, the correct answer is, so initially the gas is only 0.1 mole, that is heated to 50 degrees more. As a result, the gas will expand, but to keep the pressure constant, some gas is removed. So, when certain gas is removed, then what is the amount of gas removed is what is given, 0.8 grams, and removing that gas, pressure is again coming to the same value. So, when the pressure is coming to the same value, that is P1 is equal to P2. So, certain amount of gas is removed, this is the remaining number of moles. So, from that to the temperature to which the gas is heated is, the initial temperature is 200 Kelvin. So, the correct answer is option 3. Now, let us go to question number 34. 2 moles of a gas are confined to a 5 liter flask at 27 degrees Celsius. Its pressure using Van der Waals equation is dash. A is given, B is given. So, using Van der Waals equation, it is P plus A by V square into V minus B is equal to RT. This is Van der Waals equation. Now, for in the case of gas with having more number of moles rather than 1, this is for n equal to 1. But if other than that, P plus n square A by V square into V minus NB is equal to nRT. This here what we have to find is the pressure P plus n square, n is 2 square, A is given as 6.25 per mole, it is, by V square, the V given is 5 liters into V again 5 minus 2 into B value given is 0.037 is equal to N 2 or 0.0821 T given is 27 degrees Celsius, that is 300. So, just all the values are directly given, only the equation is big, you have to substitute all the values, calculation becomes little lengthy, but on solving all this definitely you will arrive at the answer that P is equal to 9 atmosphere. And here in solving this kind of questions, one advantage also what we can have is, try to solve the equation by taking PV equal to nRT without having the values of A and B, right. Then in this substitute these values without A and B and try to find out the pressure. If this pressure comes to any of the nearest given answers, then directly that also we can write without solving the equation with such a complicated equation and all. But anyhow, finally the answer what you will get is 9 atmosphere. So, the correct answer is option 2. Now, we go to question number 35. A straight glass tube of length 450 centimeter has 2 inlets X and Y. So, once again it is similar to one of the previous questions that what we did. The length of the tube is 450 centimeter. It has 2 inlets, one is X and another one is Y. Through inlet X, the gas with vapor density 36, that is molecular weight is 72, and through inlet Y an unknown gas is introduced. Here unknown gas, that means molecular weight is My, I will take it as, introduced at same temperature and pressure for same time. The distance of point at which 2 gases meet is 180 centimeters from the end of X. So, from here to a point X at some point, this is 180 centimeters. Then obviously, this will be 450 minus 180, that it must be 270 centimeters from the end Y. Then what is the weight of 2.8 liters of that gas at STP? Now, so for that, first what we have to do is, we have to find out the molecular weight of the gas, because now it is again, it is from the 2 opposite ends the 2 gases are allowed to mix. So, it is at what rate the 2 gases are diffusing from the two opposite ends is what actually the principle involved in over here. So, here ratio of rate of diffusions of the unknown gas Rx by Ry is equal to root over My by Mx, which is equal to Lx by Ly. So, here Lx by Ly is equal to Lx is 180 by 270. Now, therefore, root over My by Mx is 72 is equal to 180 by 270. Now, this if you solve, what you will get as that My you will get it, this My is the molecular weight, what you will get it. So, this My is equal to, so from this what you can write is this My is equal to 180 square by 270 square, 180 square 72. So, this if you do from this is all equal to this, if you divide it, it is 0.444 into 72. So, this comes out to be 32. So, molecular weight of unknown gas is coming out to be 32. When the molecular weight of unknown gas is coming out to be 32, the meaning is that 22.4 liters of that gas will have a weight of 32. That is 1 mole. So, what is the weight of 2.8 liters of that particular gas? That if you calculate, this weight is equal to, now on simplification easily you can get 2.8 into 32 by 22.4, that comes out to be 4 grams. So, the weight of 2.8 liters of that particular gas is 4 grams. So, the correct answer is option 1. Let us see the question number 36. The compressibility factor for nitrogen at 330 Kelvin and 800 atmosphere is 1.9, and at 570 Kelvin and 200 atmosphere is 1.1. Certain mass of nitrogen occupies a volume of 1 cubic decimeter at 330 Kelvin and 800 atmosphere. Then volume occupied by same quantity of nitrogen gas at 570 Kelvin and 200 atmosphere. Basically, the point is from the two equations what we get, we have to find out the values of A and B, because it is given the compressibility factor. Compressibility factor P is equal to compressibility factor Z is equal to PV by RT. So, by taking those two, the compressibility factor when it is given at two different temperatures, then from that volume occupied by same quantity of nitrogen gas at 570 Kelvin and 200 atmosphere in liters is. Straight away we can go for the from that we have to find out the volume weight of the gas, nitrogen gas at 330 and 800. Then the compressibility factor Z in the first one, if you take, so Z equal to PV by nRT, then what we have to find out is actually the N value. So, Z1 equal to PV by nRT, that if you take, that pressure is given as 800 atmosphere and temperature is 330 Kelvin and volume is 1 cubic decimeter. So, volume you take it as 1 cubic decimeter and number of moles is what we have to find out. Then R value is of course 0.0821 and temperature is 330 Kelvin. 330 Kelvin. So, from this what you can determine is the, and this is given as equal to 1.9. So, from this we have to find out the value of N. And second thing what is given, that at 200 atmosphere and 1.1 at 570 Kelvin and 200 atmosphere. Again the same thing if you do, then volume is not given. So, this N after you substituting, then the volume Z2 is equal to pressure given is 200 atmospheric pressure. Here volume we have to find out, divided by number of moles. From this whatever we get, that we substitute over here into 0.0821 into, now it is temperature given is 570 Kelvin. This is equal to 1.1. So, from this volume again you will get it. Now, volume occupied by same quantity. Now, from this you determine the quantity of the gas. So, from this what you will get, the using the same, then you apply PV equal to nRT. Then when you apply PV equal to nRT, then from this whatever the V that we get, that you have to substitute, and N we have to substitute. Then by substituting this, what you will get, the answer finally, this is a volume occupied and pressure is 200 into volume is what we have to find out now. The number of moles is given, that already we have calculated, and R 0.0821, and temperature is 570 again. So, this is the temperature and this is the pressure. Now, at this, what is the volume, that if you substitute this volume, what we are getting, that we have to substitute here. Then at this, then the number of moles we have to calculate. When you calculate the number of moles, from that when you calculate the mass, the volume occupied by the same quantity. So, this N value if you substitute over here, then you will get this volume. So, this volume finally we will get it as the 4 liters. So, again in brief I will repeat that Z is equal to this at this condition of 800 atmosphere and 330 Kelvin. Then at other conditions of 200 atmosphere and 570 Kelvin, this is given. So, from this if you are finding out the value of N, that value of N you directly take, this is in fact is not necessary. So, if you substitute that over here, then you can find the volume. So, from this you can determine the volume as 4 liters. So, the correct answer is option 3. Now, we go to question number 37. A flask contains a mixture of nitrogen and carbon dioxide at a total pressure of 1.5 atmosphere and at a temperature of 27 degrees Celsius. If all the carbon dioxide is removed, the pressure falls to 0.5 atmosphere and weight of the flask drops. Weight of the flask drops by 22 grams. The weight of nitrogen in the mixture in grams is. So, the question is, initially you have a mixture of nitrogen and carbon dioxide, and the pressure is 1.5 atmosphere for this mixture at the temperature of 300 Kelvin, right. If carbon dioxide is removed, then the pressure falls to, this is condition of condition 1 if you take, and in the condition 2 it is you have, what you have is only nitrogen. Only nitrogen when you take, the pressure has become 0.5 atmosphere. Temperature remains of course 300 Kelvin, right. Then the weight of nitrogen, now weight of the flask drops by 22. So, weight of carbon dioxide removed is 22 grams, that means it is 0.5 moles, right. 0.5 moles is removed. So, initially suppose if the total number of moles, if you consider it as N, then here temperature is constant and volume is constant. So, P is proportional to N, therefore, P1 by P2 is equal to N1 by N2, implies pressure initially is 1.5 and finally it is 0.5, that is after carbon dioxide is removed. Then here you will have initially, if you have N number of moles, now it is N minus 0.5. Now, this if you solve, then the answer what you will get, this N value initial, then N the weight of nitrogen in the mixture in the grams, that if you here what you will get is the number of moles of nitrogen. This number of moles of nitrogen if you convert into weight, then this number of moles of nitrogen, this is number of moles of nitrogen plus carbon dioxide, right. So, this is the N. From this what you will get is that this N2 plus CO2, right, into 0.5 is equal to 1.5 into N minus 0.5. So, this 0.5 N is equal to 1.5 N minus 1.5 into 5, 0.75, 1.5 into 5, that is 0.75. So, from this 1 N is equal to 0.75, means n is equal to 0.75. Now from this n minus 0.5, so here your initial number of moles is 0.75. Now from this carbon dioxide removed is 0.5. So n minus 0.5 is 0.25. That means number of moles of nitrogen is equal to 0.25. Okay. Therefore, weight of nitrogen is equal to 0.25 into 28, that is molecular weight of nitrogen. So the answer is 0.25 into 28, that is 7. So it is 7 grams. So it is all, this is initial pressure and final pressure 1.5 by 0.5. Initial number of moles, initially we have both nitrogen and carbon dioxide. Then final we have only nitrogen, so carbon dioxide is removed, so it will become n minus 0.5. That all, and if you do, then what you will get is number of moles of nitrogen, you will get it as initially number of moles of nitrogen what we took is 0.25. So the weight of nitrogen is 0.25 into 28, that is 7. So the correct answer is option 4, that is 7. Question number 38. This is a matching for different graphs. In the column 1, it is given the parameters to be taken on y axis and x axis, and on the right hand side it is given the corresponding graphs. Now we have to match for the given quantities, variation in the given quantities, what is the correct graph. Now look at the first parameters that is given in option A. So now the graph given is 1 by v square versus p. So from the Boyle's law, p is proportional to 1 by v. So when you draw a graph for p proportional to 1 by v, then p versus 1 by v is a straight line, you will get it like this. But the question given is now 1 by v square versus p. So this now 1 by v or 1 by v square, both we will get the same thing. So 1 by v square versus p when we draw, then it must be like this, is what we will get it, because 1 by v square versus p, 1 by v versus p, when you are getting a straight line, 1 by v square versus p will be a exponential increase. So this is the, that is option R is what we are going to get. Next, second is v versus 1 by t. Actually v is proportional to t. So when v is proportional to t, for that is Charles law graph. For that Charles law graph, what we will get is a straight line. Now it is v versus 1 by t. So it will be a decreasing graph. So it will be an exponential decrease. So for v versus 1 by v is actually proportional to t. For v proportional to t, you will get a straight line, but this is v versus 1 by t. So that will be a decrease, exponential decrease is what we will get it. And the next is pt versus t square. P is proportional to t, so pt is proportional to t square. So p proportional to t is a straight line. So pt you are multiplying with the same quantity, so there will be no change. So here again you will get a straight line. So this is, so for this C, the option is P. Then D, v versus 1 by v square, 1 by p square. Again it relates to this, p is proportional to 1 by v, or from this also what you can write is v is proportional to 1 by p. When the v is proportional to 1 by p, then v versus 1 by p square again will be like that exponential increase, but in the reverse direction. So it will be, this is how you will get it for what you call the v versus 1 by p square. So this is for 1 by v square versus p. This is all based on the what you call gas laws. This is with respect to Boyle's law, and then for the second one, that is for the, as this is according to the Charles law, and then this is the Avogadro's law, and of course this is again in the reverse case of what is called Boyle's law. Okay. So the correct answers are that for A it is R, for B it is S, for C it is P, and for D it is a Q. Okay? So, the correct answer is option 1. Let us go to question number 39. This again relates to graph dP versus P. First of all, P equal to dRT by M. Now, this is d by P versus P. Now, d by, so first of all, P is proportional to D or D is proportional to P. So, d by P will be equal to P by P, that is equal to 1. So, d by P versus P, what you will get is a straight line with slope 1, okay? With no slope, right. So, this is what you will get it, and this is of course drawn at a constant temperature, because d by P versus P for an ideal gas at constant temperature. Because it is constant temperature, any graph that is drawn at constant temperature is what we call isotherm. So, the correct graph is this, and this is an isotherm. So, the options are here, for each one you have two options, that is R and T. Then second is log P versus log 1 by V. So, as P is proportional to 1 by V, therefore, log P is, so this is P is equal to K into 1 by V. Let me take that K as some constant. So, log P is equal to log K plus log 1 by V. So, when you draw a graph for log P versus log 1 by V, it is of the form y is equal to mx plus c. So, then you will get an intercept of log K. So, that intercept that is, so it is corresponding to B, and this is again, so here what you will get is like this, and this is equal to this log K. So, this is log P versus log 1 by V, you are getting an intercept. So, this is log P versus log 1 by V, this is 1. So, for P proportional to, for this particular graph, it is straight line with an intercept log K, and this is again at constant temperature. Therefore, the correct answers here is option P on the right hand side and also option T, right. Then next, third one is log V versus log T. As V is proportional to T, log, I will write V is equal to again some another constant K into T. So, log V is equal to log K plus log T with, so here slope of the graph what you will get, this is again y is equal to mx plus c, but slope mx, m is equal to 1. So, slope is equal to 1, that means angle must be equal to 45. So, for this it is only c is equal to, for C the correct option is P, where it is slope is equal to what you call 1. So, it is making again an intercept log K with slope equal to 1. So, there in the right hand side we have only that P option which is making certain intercept of log K. So, that is the answer, and the last it is log P versus log V for an ideal gas at T and N, and of course, this is not an isotherm because this is not at constant temperature. So, this is not an isotherm. So, here we do not get the option T as the answer, and the last it is log P versus log V. So, P is equal to some K into or K by V, and now it is log P versus log V. So, log P is equal to log K into log K minus log K, this I will write K into 1 by V, right. So, log P is equal to log K plus log 1 by V, or I will put it as this log P is equal to log K minus log V. So, here slope is equal to minus 1, that is negative slope, and intercept again in all these intercept is equal to log K. Now, so in the graphs on the right hand side if you look at it, we have only one graph with negative slope, that is Q. Okay. So, it is the intercept is log K and negative slope. So, for the option D the correct answer is Q. So, overall finally if you look at it, and of course, this is again isotherm, because the graph is drawn at constant temperature. So you will get both Q and T. So the correct option is ART, BPT, CP, D, QT. So the correct answer is option 1. Now in the question number 40 is all it is a matching of the given parameter to the given formula, as a critical constants are given with respect to the van der Waals constants A and B. How do we get the critical constants? So as in the theory that we discussed, critical temperature is given with the formula ADA by 27 RB. Critical pressure is given by A by 27 B square, and Boyle's temperature is 2A by RB, and inversion temperature is A by RB. So it is A critical temperature ADA by 27 RB AS, Boyle temperature B is A by RB. So that is Boyle temperature is A by RB. So it is the option P. Inversion temperature is 2A by RB, right, and critical pressure is A by 27 B square, that is R. So AS, BP, CQ, DR, that is option 3 is the correct answer.